Hello, this is Kieran from cryptobulls, and today we're going to understand the basics of blockchain. In our fundamentals section, you will learn what makes a blockchain so special, how it works, and why it has the potential to influence many areas of our lives. In this video, we will talk about what is blockchain, properties of a blockchain, decentralization, reversibility, transparency, anonymity, advantages of the blockchain technology, safety and security, trust, low transaction costs, access, how does blockchain work, private and public address, distributed ledger, why the name is blockchain, hash values and cryptography, mining and blockchain reward system, proof of work, understanding what smart contracts are, how they work, how they can be used, and ICOs and DAPPs. So that's a lot, so let's get to it. What is blockchain? In short, a blockchain is comparable to a database that does not belong to anyone and belongs to everyone at the same time. Due to these other characteristics, the blockchain solves trust problems that often arise in our economy and society. A blockchain is therefore often referred to as layer of trust or trust machine. The blockchain is a new technological development that can fundamentally change the way we communicate and interact around the world. Due to its characteristics, it is said to be able to change the entire industry and branches or even make them superfluous. This disruptive approach is based on the way it works. Blockchain should make it possible to guarantee an unlimited exchange of information, values and goods of any kind without having to resort to intermediary institutions such as corporations, banks or governments. To this end, technology replaces the task of the intermediaries, namely to minimize uncertainty and create trust. The idea of a blockchain was first published in 2008. Although the underlying technological concepts go back much further, the original idea was to use the blockchain to create a decentralized currency free from the influence of banks and governments. This currency was called Bitcoin, and it still represents the technology today. To this day, no one knows who really wrote the white paper on Bitcoin, as the only author who was responsible for it was the person or group under the pseudonym Satoshi Nakamoto. Bitcoin was the first decentralized currency based on blockchain technology. Since then, blockchain has become a phenomenon that employs private individuals, governments, companies and public institutions alike. Both the technological possibilities, disruptive ambitions and financial investment opportunities of the blockchain are attracting great interest. The former in particular triggered a gold rush mood and billions in investments, which is why there is often talk of a speculative bubble. However, these distractions often drown out the actual potential of this revolutionary advancement. Due to the worldwide fascination, the emergence of blockchain is also compared with the emergence of the internet in the early 90s. It is therefore worth taking a closer look at the technology and its properties. In summary, blockchain is a decentralized peer-to-peer network that generates a secure, transparent and optionally anonymous system with the help of cryptography. This minimizes uncertainties and transaction costs, makes trust in system participants obsolete, and presents the exclusion of persons. In order to make this definition more understandable, the individual points will be examined in more detail below. So here are the properties of a blockchain. First of all, it's decentralized. Second, it's immutable. You cannot just change it. It's transparent, you see the transactions. And it's anonymous in the sense that you don't know who is behind an address. Decentralization. The shift away from centralization is one of the most important characteristics of blockchain. It describes the power relations within a system which are evenly distributed. The aim is to prevent the emergence of central parties. Institutions that in such central positions today are, for example, banks, governments, or companies that are in monopolistic structured industries. Irreversibility. All information that has ever occurred on the blockchain is stored irreversibly. A block represents a combination of the most current information of the system. They are connected one after the other and form a blockchain, which is constantly extended with new information by further blocks. Once a new block has been concatenated with the previous one, it is stored in an unalterable form along with its stored information. Transparency. The blockchain is transparent in the sense that all accesses and interactions in the system are openly visible and irreversibly documented, so that it is possible to see every piece of information but not to change it. No information is deleted, but information about the change of circumstances is added so that every change and every access in the system can be traced back to its origin. Since the control of this is distributed in a decentralized way, there can be no non-transparent processes. Anonymity. One of the most discussed characteristics of the blockchain is the anonymity of its participants. While all access and activities of the participants are transparent, the participants themselves are only represented by cryptographically encrypted number series. Depending on the type of blockchain, it is very difficult or even impossible to trace the real identity of a participant. The advantages resulting from the above-mentioned characteristic are wide-ranging. So now we talk about some advantage of blockchain technology. Safety and security. The combination of decentralization, irreversibility, and transparency creates, in theory, a perfect fraud-proof system. The blockchain always stores and updates the complete history of information that has ever occurred within the system. This special feature lies in the principle of decentralization, which means that this history is not stored centrally, but separately for many individual participants. In order to manipulate the system, it would therefore be necessary, in theory, to manipulate every single blockchain of information for countless participants at the same time, which is considered to be virtually impossible and not economically worthwhile, especially for Bitcoin. The more participants a blockchain has, the more secure it has as a rule. Trust. The security of the system makes trust in other participants, intermediaries, brokers, superfluous. Any interaction is therefore free of uncertainty or fear of fraud. What used to be the task of intermediaries, such as governments, banks, or corporations, is now being taken over by blockchain technology. Because of this characteristic, blockchains are also known as trust protocols. Low transaction cost. The use of intermediary institutions usually leads to transaction costs. For example, the costs of a service consisting of creating trust and security between actors are charged, or costs are incurred in the course of the processing or administrative efforts. Blockchain technology makes these services in part superfluous and allows direct P2P interaction, peer-to-peer, without transaction costs in the form of fees or contributions. The purchase of a used bicycle, the sending of money, or the booking of a flight can thus be handled without fees due today. The transaction costs for participants within a blockchain can consequently be minimized. Access. Prerequisites for participating in a blockchain system are relatively low. All you need is a device with an internet connection. More than 4 billion people worldwide now meet this requirement, and that is far more people than, for example, those who currently meet the requirements for a financial service or insurance from a central institution. Blockchain opens up international exchange and trade to a large part of the world's population that was previously excluded. How does blockchain work? The blockchain is based on a simple P2P database. Within this database, participants can interact directly with each other. There is no central part that takes care of regulation, control, steering, or account management. This characteristic appears trivial at first, but is enormously important. Many current applications also seem to allow you to interact directly, but do not in reality. whether it's a messenger service like WhatsApp, a payment service like PayPal, or an online marketplace like eBay. There's always a central party involved that stores information, charges fees, or determines which participants are allowed to participate in the system when an account is opened. Private key and public access. Among other things, the peer-to-peer leads to decentralized account management in the central system. The account is opened via the intermediary, such as a bank account, or the creation of a mail address. The intermediary can avoid duplicate addresses by reconciliation and collection of information and data about the person. In the decentralized network of the blockchain, accounts are generated randomly by the means of cryptography, without the accounts being reconciled with each other. When an account is created, each participant receives a randomly generated private key, a kind of password. There are 2,256 ways to create it, which are about as many variations as there are atoms in the universe. A double-generated private key is therefore considered virtually impossible. It is usually displayed in hexadecimal form, consisting of a combination of 64 numbers and letters, and looks like this. Note that there is no 0 or O's to avoid confusion. A so-called public address is then derived from this. It behaves similarly to the private key as the mail address behaves to the password and represents the own account in the system. This derivation only works one way. You cannot derive the private key from the public address. If the information is to be transmitted, for example, about the ownership of a certain amount of Bitcoin, it is sent to the public address of a person. For example, if Jessica wants to transfer 2 Bitcoins to Max, she logs into her account with her private key and defines Max's public address as the new owner. Only Max now can access it using his private key and make further changes. Independently of this, anyone can view the transaction of all addresses with each other. This transparency is based on the principle of distributed ledger and will be explained in the following section. Let note that we are in a peer-to-peer system in which participants interact cryptographically in encrypted accounts. Distributed ledger. A special feature of the system in the way of which information is processed and documented. This is done using a distributed ledger, which can be interpreted as a distributed accounting ledger. It more or less replaces the central server on a system. 2 characteristics of this are decisive. On one hand, all new information gets an entry into the accounting book, even if previous information is only to be changed or made void. Once an entry has been made in a ledger, it cannot be changed. More about this later. Instead, the adjustments of the previous information is inserted in the new entry. For example, if Jessica has transferred 2 Bitcoins to Max, this information gets an entry. If Max then returns the 2 Bitcoins to Jessica, which would restore the old information, the old entry will not be deleted. Instead, a new entry is added with the information that the 2 Bitcoins were transferred back to Max to Jessica. At the same time, the complete ledger of accounts is updated with each new entry, copied and made available separately to everyone who is actively involved with the operation of the blockchain. This ensures an aspect of decentralization. In our example above, if Jessica wants to cheat the system and say that she never received a refund of the 2 Bitcoins from Max, she can now be proven guilty of this lie because there's a decentralized, publicly accessible ledger in which all information and transactions are documented. Remember that we are in a tamper-proof and transparent peer-to-peer system where information is decentralized and participants interact using cryptographically encrypted accounts. Why the name blockchain? Let us now look at the entries in the account book that gives the blockchain its name. Each entry consists of several pieces of information which together form a block. These blocks are arranged one after the other by cryptographically concatenating the most recent block with the previous one. This creates an unchangeable chain in which older entries can no longer be changed. This is due to the type of connection, which is based on a unidirectional cryptographic concatenation. When each block is created, certain information is added to it, including a header, an ID, a time value, and a so-called hash value, as a reference to the hash value of the previous block. Hash values and cryptography. The hash value is a value derived from a digital content by means of complex mathematical calculations, in this case the information of a block. The hash value is always identical if the content does not change, and the same hash value can always be calculated from the content. However, you cannot derive the content from the hash value the other way around. A simplified example shows the sum of digits. If the content of a block consists of the numbers 1, 3 and 4, the checksum more or less the hash 8. The checksum can be derived from the content again and again, simply the hash. However, this is not possible the other way around, since the checksum 8 can also consist other number combinations such as 224 or 116. In reality, the formulas for calculating the hash value are much more complex, so that the change in data is immediately noticeable. Bitcoin, for example, uses SHA-256 method. An important point here is that the hash function used provides what is known as collision resistance, which makes it impossible for different contents to create the same hash value. Each block has a digital fingerprint that uniquely identifies it and also links it invariably to the neighboring blocks. If one would change the information from an old block, all subsequent blocks would notice this, since the respective hash changes with each one. Remember, we are in a tamper-proof and transparent peer-to-peer system where information is decentralized and immutable, and participants interact using cryptographically encrypted accounts. The blockchain represents the blocks interlinked by hash values, which contain the information of the distributed ledger. Mining blockchain reward system. The value of the blockchain is thus based, amongst other things, entirely on the secure documentation of information within the blocks. In order to create such a block, including its hash value, a considerable amount of computing power is required. The larger a blockchain becomes, the more complex the process gets. The question that arises is who provides the computing power to generate the blocks and keep the system running. For this, we turn to the so-called miners. The miners are participants in the blockchain network who voluntarily make their computing power available to validate information and create blocks from it. They are existential for the system. A financial incentive is offered to ensure that there are enough miners. Each miner receives a defined amount of cryptocurrency, Bitcoin in this case, for his performance, which can be monetized. Since there can be several participants within a blockchain who want to perform profitable computing work, there is then a competition. On the one hand, this ensures that only one block is attached to the chain at a time. On the other hand, the competition determines which participant is awarded the prize. This agreement between the miners is so-called consensus. There are several ways to reach a consensus. Proof of work. Currently we refer to the variant on which Bitcoin is based on as proof of work. Here the time and effort determines who is awarded a specific amount of Bitcoin. To achieve this, participants or their hardware must complete complex arithmetic tasks that basically consist of guessing complicated hash values. The calculations run automatically by computing power. Whoever solves the task first is awarded the prize for the creation of a block. As soon as the winner has created the block, he passes it on to other miners in the system for control. After a certain number of checks, the block and underlying information are considered valid. This process is initiated on a new basis for each block. The POW algorithm and the resulting computing effort also prevent so-called Sybil attacks. In a Sybil attack, countless fake participants are generated in order to influence majority votes. For example, whether a block is valid or not within the blockchain. To summarize, it is important to remember that we are in a tamper-proof and transparent peer-to-peer system. And a consensus algorithm, proof of work, uses special procedure to determine which participants are selected. What are smart contracts? Smart contracts, also called intelligent contracts, constitute of a functional extension to the classic blockchain system and are attributed to the second generation of blockchain. The Ethereum blockchain in particular represents the use of smart contracts, as it was one of the first technologies to create the technical prerequisites for their full use. How do smart contracts work? Basically, smart contracts are small programs that run on a blockchain and are based on a simple if-then function that they can execute automatically. Similar to a traditional contract, conditions and actions are defined. Intelligent contracts benefit from the properties of the blockchain and are unchangeable, transparent, and do not require an intermediary for processing. Instead, the functionality of the blockchain ensures secure execution of contracts at a minimal cost. The advantages are versatile. Smart contracts can be executed automatically and without loss of time, without being dependent on intermediaries or high transaction costs. Within a blockchain, a smart contract functions as a separate account with a public address, but without an access holder. Virtually nobody owns the private key to this account. Once it has been created, no one can access it or make any changes. Instead, the contents of the contract are laid down in the form of conditions and actions that the account automatically executes. It can also connect to other accounts with which it is expected to interact. To do this, the respective account holders must accept the contracts in advance using their digital fingerprint. How can smart contracts be used? The fields of application for smart contracts are immense. Some simple examples are illustrated below. The use of repetitive payments should help to make this approach clear. In the conventional blockchain system, for example, Jessica can carry out her monthly rent by transferring 2 bitcoins to her landlord, and in return is granted the right to move into the apartment. However, she would have to repeat this process every month, similar to an automatic bank transfer. With a smart contract, Jessica can conclude a contract with her landlord that carries out a recurring and automated payment. To do this, she first defines the conditions that the first day of each month must pass. If this condition is met, a corresponding transaction is initiated from her account via the smart contract to the landlord's account. If the landlord and Jessica agree to this contract, the smart contract will connect to the respective accounts. What sounds like a simple transaction at the bank is now possible with any intermediary, in this case, the bank. Theoretically, further flatmates could be added to the smart contract, or it could be defined that additional cost repayments remain on the smart contract account in order to offset them against future rents. Another interesting case is decentralized power generation, in which private solar power companies and consumers without intermediary connect with each other. The blockchain can document both the amount of energy used by the consumer and the amount of solar production in a decentralized and tamper-proof manner. This is done, for example, with intelligent light bulbs that feed information about electricity consumption directly into the blockchain. Smart contracts could automatically initiate the corresponding payments from consumers to producers. In such a system, electricity companies would be superfluous, since trust is created by the blockchain and smart contracts take over the contractual terms and automatic payments. The actual possibilities for smart contracts go far beyond the examples above. Smart contracts can be designed as complex as necessary and can contain numerous parties and conditions. As soon as conditions and actions are defined and digitized, smart contracts can take over this work. As digitalization progresses, the work of lawyers, notaries, or authorities, for example, will be made easier or even redundant. The Internet of Things could be used the interface of the blockchain to automate invoicing and payments in real time. Initial coin offerings and DAPPs. Smart contracts are already in use in the area of ICOs, initial coin offerings. These are swarm investments made by companies in which a payment to a specific account directly initiates a repayment in the form of tokens. Smart contracts can even automate entire businesses. If several smart contracts are linked together, complex programs can be designed that are decentralized through the blockchain. These applications are called decentralized apps. One of many examples would be Golem, a decentralized network for renting and leasing computing power. Essentially, many cryptocurrencies that do not have their own blockchain infrastructure are merely complex steps that run as a program on an existing blockchain. One can compare this model with that of an online web service for which one pays. A good example for this is the Ethereum blockchain, which provides its sophisticated operating system called Ethereum Virtual Machine (EVM), so that the tenants can run their programs or applications on the EVM. They have to pay for gas. In the EVM, gas is paid for in the currency of Ethereum, Ether, at which point the program code of the application is executed in the entire Ethereum network, and the tenants can run their programs on the EVM. Moreover, since most blockchain technologies are based on the open source principle, the possibility to create innovative dApps is available to everyone. It will therefore be exciting to observe which decentralized applications will influence the private as well as the professional environment in the future. So I hope you enjoyed these blockchain fundamentals and learned something new. I will catch you on the next one. Hope you have a great day and see you next time. Bye bye.